Let's go on to example 3, where this time we have algebraic expressions that we're simplifying. And things are going to work a little bit differently here because we have variables. We're going to have to be really careful when we simplify in the placement of those variables in our expression. So I'll show you what I mean by that. Log x squared base 7 plus log x base 7 minus 5 log x base 7 all over 2. Okay? Before we try and simplify this into one single term, into one single logarithm, I want you guys to think about the potential values that x could take on. Or another way of saying it is, what values do I have to restrict x to because it finds itself inside of a logarithm? You'll remember when you deal with things like square roots, because the variable finds itself inside of a square root, it has to take restrictions. You can't have negative stuff inside of a square root. When you have variables in the bottom of a fraction, you have to restrict that value because you can't divide by 0. Same thing with logarithms. Because there's a variable inside of a logarithm, it will take on restrictive values. So I want you to think, just maybe think about the first term there. What can x not be? This is in a exponential form. 7 to the power of something equals x squared. What can this not be? I raise 7 to a power. What kind of numbers can I not get?
Decimal.
You can get decimals. You could get 1. I could raise 7 to 0, and that would get 1. Negative. Right? I can't raise positive 7 to any power and get a negative value. Right? Okay, so x can't be negative. What else? There's one other value it can't be.
7.
It could be 7. I could raise 7 to the power of 1.
7.
Right? 0. Why can't x be 0?
Because 0 to the power of anything is 0.
Yeah, and my base isn't 0, right? Or I try to raise 7 to any power and I will never get 0. The smallest thing I can get is 7 to the 0, but that's just 1. Well, actually, that's not the smallest thing, but because I could also square root it. But that's definitely the smallest. Well, I could use negative exponents too. Point is, there's no way I can put an exponents for 7 and get 0 to pop out, or a negative value. So the restriction that we need on x, because it's in a logarithm, is x has to be greater than 0. Can't equal 0 because there's no way to do it. Can't be negative. Can't be less than 0 because you can't get negative values. Does that make sense? Okay, so we're going to need that. We're going to need to restate that restriction just at the end with our final answer. We're going to take all 3 of these terms and combine them into one using the laws of logarithms, and then state that restriction at the end. With me? So it's just like what we were doing before.
A little bit.
Okay, so I'm going to combine these first 2. What do they combine to?
X squared times x.
Pardon me? X squared times x, right? So this would be log x cubed base 7, right? Because it's x squared times x. And then I have minus 5 log x base 7 over 2. What to do now?
Factor the 2 out.
Factor the 2 out?
Mm-hmm.
What do you mean this guy doesn't have a 2?
Times everything by 2.
Can't do that, it's not an equation. If it was an equation, it'd be nicer. Yeah. One thing we could do is I'm going to rewrite that second term, I'm hoping this will work, as negative 5 over 2 log x base 7. We'll follow what I did there? Because 5 over 2 log 7 is the same thing as this, right? If I multiply the 5 by the top. Okay. what to do from there. Any ideas? Huh?
Make it the exponent.
Yeah, I'm going to make it the exponent.
So it's x cubed root x to the power of 5.
So this would be x to the power of 5 over 2, which is the square root of x to the power of 5, right? And then I'm going to combine these two logarithms into one. Okay? So that's log x cubed over x to the 5 over 2, all base 7. Getting a little closer. We are allowed, I just want to note here, we are allowed to put x in a denominator. You have to be careful when you do that with variables, but we're allowed to do that. Why? How do I know it's not going to be 0, right? I restricted it. Okay? So I'm allowed to do that. You have to be careful when you put variables in denominators. Okay, so what happens when I divide two powers? I keep spoiling the surprise, man.
You divide.
No. You subtract the exponents. So 3 minus 5 over 2, which is 3 minus 2.5, so 0.5 or 1/2. Can I skip the work? So that's x to the 1/2, base 7. And you could write it a little nicer. You could write 1/2 x base 7. Maybe that's a good way to do it. Or log root x base 7. Either way. We have a single term now, or a single logarithmic term, and we got a state of restriction. X has to be bigger than 0. Make sense? So I know. Maybe you're wondering to yourself, well, how do I know to do this, and how do I know to do this? And experimentation. Okay, practice will give you the intuition that you need to know what to do. Okay.